Okay, well, thanks everybody for coming to today's webinar Wednesday on plant floor cybersecurity. Your cameras and microphones are turned off to keep things running smoothly. If you have any questions, please post them in the chat and we'll answer them as we go. This training will be recorded and posted online for future viewing. So let's get things started. I'm going to turn off my camera so you don't have to look at me through this and just look at my slides. Thanks. So we're going to talk today about first principles, foundational concepts, and how you can get started on your own cybersecurity journey within the OT realm. The intent here is just give you some high level concepts to get started or figure out where you are. And not going to get very technical today, but again, always happy to answer any questions that may come up regarding that. So this is what we're going to cover. So cybersecurity first principles, kind of what they are, how we can make use of them, cybersecurity foundational concepts, specifically within OT. We'll talk a little bit about what OT is, how it looks different than maybe an enterprise IT system, and then helping you map out your OT cybersecurity journey. You know, what tools are available, how and where do you start, who can you turn to for help, those sorts of things. So speaking of first principles, the concepts we're going to cover today comes from this book as shown on the screen, Cybersecurity First Principles, a reboot of strategy and tactics by Rick Howard. It's a really good book. At the end of this, we'll have some links to any of the stuff I cover here, along with some other things we've developed about OT cybersecurity over the last few years. But you know, this first section of this is specifically about first principles, and this is where the ideas for that come from. So when you think of first principles, a lot of people think, well, the CIA IAC triad, is that a first principle? And what I mean by that is the confidentiality, integrity, and availability of data. Although in the OT world, it's usually mostly integrity and availability, not instead of, but at a higher priority than confidentiality. And pretty much the answer is no. The CIA concept has been around since the 1970s, and just stating your principles and your priorities doesn't really lead you to a solution. So that doesn't really make for a good first principle. Everybody in your organization is going to have different ways of achieving these priorities and goals, and they may have different priorities than you. So is adherence to a cybersecurity framework a first principle? Again, not really. Even though a framework gives us a path to follow, usually they're used to copy a commonly accepted mature model that cybersecurity implementers can use. They can then take to their leadership and say, look, we use best practices. The one failing of it, though, is to go through the cybersecurity framework one time and think that you've accomplished the entire goal from here on out into eternity. And what you've done is you've captured a snapshot. So again, still doesn't really address what a first principle should be. The other question we get sometimes is regulatory compliance a first principle? Close, but not quite. So while adhering to and complying with regulatory requirements, that being very important to do, especially if you're a utility or life sciences and pharma, where you have, or food and beverage, where you have municipal or federal guidelines and compliance regulations to adhere to. Again, that doesn't really address the first principle. It doesn't identify your prime mover. It doesn't identify what you're trying to do. It kind of says you have to do these things, but how you do them and what they mean to your organization may be different from a very similar yet different organization. So now that we know all the things that a first principle is not, here's a clue as to what it is. So according to Rick Howard, reduce the probability of material impact due to a cyber event over the next 3 years. That's a good first principle because it gives you a goal, and that goal leads you into a framework and the ability to do a number of things with it, right? It's not very prescriptive, but it also gives you a something to focus on. So you're trying to reduce the probability of something happens. Notice it doesn't say reduce any occurrence of a material impact. What you're trying to reduce is the material impact due to specifically a cyber event, and you've given yourself a timeline of 3 years. So this may be perfect for your organization. It may be a little different, but I would suggest kind of going with this as a good framework to start with. Well, sorry, not a framework, it's a first principle. So that would be, my suggestion. Take something like this, make it your own, and that will help give you some goals, set your priorities, um, be able to better relay onto leadership what you're trying to accomplish. There are some times when you will have to decide all these things. Other times, leadership in your organization may tell you what it is. They may say, okay, we have a 2 year timeline to get the first pass done. And then from there, show me a 5 year plan on how to maintain this and whatever else. But in the end, you want to be not super prescriptive about what the journey looks like, but you want to be specific in that this is your goal and this is your timeline. So before we continue on to foundational concepts about OT and OT cybersec, anybody have any questions? Don't see anything in the chat at the moment, but if not, we'll continue. And again, just put your questions in the chat and I'll try and answer them as we go along here. And there'll be a little bit of time at the end as well to cover any other questions. So what is OT, as we've been calling it, or operational technology? So while IT or information technology is focused on helping an organization communicate ideas and store, retrieve, protect information, OT is focused on high speed and highly available cyber physical systems that manufacture goods, provide utilities and services to customers, and control life safety systems. So pretty much what we're talking about is anything that could be a utility, a manufacturing plant, a distribution center, a really nice, easy equation that I've seen a lot, which kind of distills this down to a simple concept is this: OT equals IT plus physics, and Dragos uses that a good bit in a lot of their documentation, their webinars, things like that. And it's simple, it's straightforward, and it you can go deeper in the definition, but as a top level concept, if you're trying to explain this to somebody, this one is perfect. So how is OT similar or different to IT? So it's similar in the use of the hardware, any of your switches, cables, VLANs, subnetting, network segmentation, all the typical things you would normally do at an IT level. You want to accomplish those things hardware-wise at the OT level. There really isn't much difference aside from some minor details in how you might use that or how you might set things up for the high availability part of it. But it's really different in the way that firmware and software are kept updated and patched and how frequently those updates can be done. CVEs, or as you see up there in the upper right corner of the screen, common vulnerability and exposures, they're graded differently. So you may have some sort of Microsoft CVE come out for, say, DCOM, which was one we had a couple of years ago. The way it's graded for IT versus OT may be different, even though it's the same vulnerability, just because of how it affects different things. It may have a higher risk score in IT than OT, or it may have a higher risk score in OT versus IT. So typically we hear the Microsoft Patch Tuesday thing where all our computers get the latest updates and whatever else from Microsoft on a weekly basis. In a plant, that could be disastrous. You install a patch on one part of a server, and that patch or that version of the OS hasn't been tested at the right level of depth with all the vendors you might have, whether it be Rockwell Automation or another automation vendor. Everybody does their own testing and releases things, is saying, yes, this works with this version of Windows desktop or Windows Server. And to arbitrarily apply those patches without trying them first in a sandbox or non-production situation can lead to a lot of downtime. Same with upgrading firmware on a PLC. In our ControlLogix processors from Rockwell is a good example. Sometimes you can upgrade a firmware 2 or 3 versions and not have any issues with any of the Ethernet cards that talk to remote I/O or drives or servo motors, anything like that. So part of the testing would be to trial those things out in a non-production environment. Rockwell does a nice bit of guidance with their PCDC, their product download and compatibility website, where you can put in different versions of hardware, different models of hardware, and see which versions of firmware work with others or not, or which OSs and things like that. So we have tools that do your first step, but again, it's not a matter of just blindly downloading updates to those production systems. So this kind of leads to the last question: is the separation between IT and OT clean or smushy? And the answer, unfortunately, is yes. There are reasons, concepts, and technology, like we just reviewed, to keep the two domains separate, right? You want to have your enterprise with its priorities on security separate from the OT and its different yet similar priorities. But sometimes you're going to have to transfer data between those two domains. And the example I have here is from an ERP. You'll have an order come in from the ERP to get downloaded to a production line or to a department to work away a list of orders. So they'll manufacture those orders, and as materials are used, typically you will use some sort of MES or manufacturing execution system to take those orders from the ERP, put it down to your plant floor, and then after those batches or runs or whatever are done, it gathers up the material usage, any batch reports, things like that, and uploads them back to the ERP so that if materials have to be reordered, the purchasing agents know when to reorder those things, especially if it's raw materials that have shelf life or anything else. You don't want to arbitrarily order 3 tanker trucks of cream or milk or something like that every week if this week you needed 2,000 and next week you needed 5,000. So just an example. So that they typically live in separate domains, but there are points at which they connect, and that's usually where both IT and OT teams have to work together. Historically, things have been antagonistic in that department, but as we try and migrate and bring things together for better connectivity, better information, faster information, actionable data, that's changing. So it's nice to see that. So now that we've kind of talked about OT conceptually, what does one look like? And I prefer to use the Purdue model. There's other models to do this, but this does a really nice job of dividing up the plant floor and the enterprise into its different domains. So we have here level 0, we have all of our sensors and actuators. Sensors are the devices that feel things, whether it be temperature, tank levels, pressures, and actuators are the do something parts of a system. So motors, servos, any kind of pneumatic or hydraulic cylinders, those sorts of things. The next level up is the PLCs or RTUs, or remote terminal units and programmable logic controllers. These are the brains, so they'll take in all the information from the sensors, run through a program or an algorithm, decide what to do, how to do it, how quickly to do it, and then they tell the actuators to do something, and it just goes like that over and over and over and over, many tens of dozens of times a second at times. The next level up is level 2, and that's where we have things like the start of our network infrastructure. We have a HMI, which is a human machine interface, and that is typically the computers that our operators will use to start and stop individual pieces of equipment or maintenance Folks will use it to calibrate sensors or calibrate a servo position, something like that. We use it to start batches, those sorts of things. And then we have SCADA, which is like a similar but higher level. So that's uh, some people call it SCADA or SCADA, but supervisory control and data acquisition or data acquisition. And that pretty much is the start of collecting all of that sensor data, runtime data, any materials that were used, and then feeds that up into historians where a lot of the literally historical data is kept, engineering workstations that are used to make changes, calibrate things outside the world of the HMI. And as it's showing here, there's a firewall to the DMZ. A lot of times this is called level 3.5. And depending on whether or not there's just one firewall here or another firewall, this is usually its own little domain where uh, a lot of more computational, more enterprise things happen. A lot of times your engineering workstations may be in here as well if you're designing a true industrial DMZ with another firewall right here. And then what we typically consider the IT domain or the enterprise would be levels 4 and 5. So you have PCs, workstations, mail servers, DNS, the traditional IT world of equipment and systems, and then you have your firewall that goes out to the universe and to the internet. So before I continue here, does anybody kind of have any questions or actually have questions on what we've covered with that so far? I don't see anything in the chat. So, okay, we'll continue. So your OT cybersecurity journey. So we've covered first principles. We know what an OT system looks like, how it ties into the IT world, how they relate to each other. So let's talk about a tool that we like to use here at Shaler Yesco. We know that Rockwell Automation uses this tool as well. It's the NIST Cybersecurity Framework. So NIST is the National Institute of Standards and Technology. They've done a lot of work. This document is now up to version 2. It's been out for about a decade plus or minus. And the nice thing that was added to version 2 is this yellow circle in the middle. That's the governance. So before it was just these 5 other steps around the outside, but the governance is nice to have it included because that is the driver for a lot of the work we do in using this cybersecurity framework. So governance are things like your computer use policies, your cybersecurity policies. They're the things that are driven at a corporate level, enterprise level, those sorts of things, sometimes even at a plant level because of many different reasons. So the fact that that's been worked in now and everything is tied into that is a really nice improvement in the version 2 of the NIST cybersecurity framework. So just kind of working our way around the outside of that. So governance is the organizational context, risk management strategies, roles, responsibilities, policies, and procedures. So what are we doing? Who's in charge of it? Who's responsible for it? Those sorts of things. Identify, and this is typically where we get involved with a lot of our customers in helping them identify. We have a lot of automation assessments through our services group that can help you identify what equipment you have, its life cycle, those kinds of things. It's hard to protect things that you don't know are in your plant. They can be blind spots, it can be vulnerabilities. So knowing what you're trying to protect is a really good place to start with that. The second step is typically protect. So that's where you have awareness controls, awareness and training. So if you have a corporate policy on doing phish email testing, where once a week, twice a week, you are delivered a fake phish email, you have to identify it, report it to your IT group, and then you get a kudos for identifying something. And it gets everybody into the habit of being and having an eye out for that. And also, this is the playbook. This is our response, right? Countermeasure deployment, data security, maintenance. So a lot of things, um, products even like Asset Center or the Factory Talk Hub Vault, where you can store your programs, having backups of data, of systems, of your automation programs and your PLCs, touchscreens, things like that. And then this is kind of where some people will start their NIST CSF journey. If they haven't started at the beginning, sometimes you're forced because of a cyber incident to start in the middle. So you want systems to do anomaly and event detection, security continuous monitoring, and what is your detection process. The place where a lot of people unfortunately end up starting their cybersecurity journey is in the respond. There's been an incident, they weren't prepared for it, they don't have a playbook, they just need help getting their facility back up and running. With a lot of incident response retainers, is almost always a good first step if you don't know even where to start, because you can get that, you'll be covered, you'll have a phone number to dial if you have any kind of event or incursion. But at the same time, because it's a retainer, you can work those hours away by doing audits, by having help writing your response plans, your playbooks, anything like a tabletop exercise where you run through simulated attacks to test your playbooks, right? You got to know, you got to be able to identify things, and then you have to know how to escalate that through the proper channels. And then the last part is recover. Making sure that your backups work, making sure that you have access to them. If they're stored off site, is it easy to get to, or do you have to fly, backup disks overnight from some vault somewhere? So we've kind of looked at first principles. We looked at OT. We know what our cybersecurity journey looks like using the NIST cybersecurity framework. If you're unsure of where to get started with this, I would invite you to call us, because if you're looking for somebody to help you, absolutely have us help you with that. Shaylee Esco, along with our Rockwell Automation contacts and their partners shown here, companies like Cisco, Dragos Clarity, Dell, Osm, CrowdStrike, Fortinet, Verve, they all have a part to play in this ecosystem. And with our access to them either directly or through Rockwell, there's a lot of things we can do to help you be prepared or more prepared. So that's my presentation. If you want more info or want to discuss any of these topics with us, info@sydist.com. And then I'll just, we have a few minutes left, about 6 minutes left on the timer here. So I'll open up the chat again for any questions. If anybody has something, I know sometimes it's hard to ask questions with this topic without revealing things about your company or your preparedness that you prefer not to. Totally understand that. But if you have general questions on what we've covered, feel free to ask away in the chat. And again, if you have other questions you want to look at more in depth or at a technical level, please feel free to reach out to us and be glad to talk to you. Yeah. Well, thanks everybody for stopping by today and participating in the Plant Floor Cybersecurity webinar Wednesday. Hope to see you soon with our next one.